by itself as it is. The issue is u substitution doesn't work. You might be thinking like secant squared, maybe there's something like tangent involved, and it doesn't, it's got all these little things that make it seem like it would be nice and easy, but it's actually a pretty complex little deal. There is a need, now and later, for what are called power reducing formulas, and it's a fancy word for something you already know. The squared is what's bothering us. So what we have, how about formulas? Formulas would be better. So power reducing formulas are ways of taking that sine squared and turning it into something that isn't that high of a power. So we're going to turn it into a single degree instead of a squared second degree function. This is the one. It's actually power reducing formulas are double angle formulas. It's code for double angle formulas. So there's a couple. Cosine of 2x is, if you remember, cosine squared. We're going to write these up real fast. Minus sine squared. This is not power reducing because all the degrees, well, I should take that back. It is. If I look at the right hand side, degree 2 functions over there, and then on the left side I have a degree 1 function, you can swap out cosine squared minus sine squared for cosine of 2x, degree 1. Here's why that is advantageous. This is a temporary marker, and I'm going to remove this. I can integrate the left really easily, and I can't integrate the right very easily. It's a little more complicated. So they become useful swaps. So back to my red color. I'm going to use the other versions of cosine of 2x. There's a couple more. If you divide both, if you divide over by cosine squared on this side, or we can replace cosine squared with, do you remember cosine squared is 1 minus sine squared? This is an aside. That's not power reduction, that's just a trig identity. If I use that little substitution right there for my cosine squared you see here, so I'm going to take this little guy and stick it right there. The other formula I get, I'm going to eliminate that, is that 2 sine, 1 minus 2 sine squared. Remember all these? It's been ages. You had a list. You didn't have to memorize them, you just had them on a sheet. If you take out sine squared and put in 1 minus cosine squared, remember that? This can go in for sine squared right there, and then the next, if you simplify just a little bit, you get 2 cosine, oh come on, wrong color, 2 cos squared x minus 1 on the other side. That sound oddly similar? Well, these are all power reducing formulas because they take what's on the right with degree 2 stuff and turn it into cosine of 2x, which is a degree 1 function. We can do it with sine of x too. We have some formulas for that. So it's basically our old double angle formulas. So it's like, it makes me think of like secret agents. These are like double agents, but we won't call them double, we'll call them double angle formulas. We can call them the double agent formulas. Let's do that. These are the double agent formulas. My wife just sent me a how are you with a heart. That was really, that makes me feel good. Okay. It didn't show up on your screen. I thought maybe it did at the top. Just you didn't see that? But you heard the ding. Okay, good. Just check. Okay, sine squared. Out of there, sine squared. I'm done with you. See this one right here in the formula thinger-binger? Check this out. See that right there? That's what I'm going to use to replace my sine squared. So, in the future, we will make your life a lot easier. I'm going to save us a little time here for a minute. Will you believe me if I do some algebra and not tell you how I did it? Does that freak you out? Or can you handle it? Because I need to buy some time here for a minute. If I were to solve that yellow formula up top, that's what I get if I isolated sine squared. Just believe me, or I'm sure your algebraticians at the top of the utmost quality. What that allows me to do is turn this little buddy into 1/2 1 minus cosine of 2x. Because degree 1 trig functions, we can change those out. We can integrate those, almost all of them, without any trouble. So that's a lot better. And it's equivalent. Also cool. Okay, so here goes. We go 1/2, the integral of 1 is just x. And then cosine of 2x, that's going to be like a u substitution. If I made u equals 2x, can you picture the 1/2 coming out front? It's going to be 1/2 sine because of that compensation for that. So if you want to do long, it's fine if you just do regular u substitution. Just call it 1/2 du is dx, and you'll see it all come together. We can do it mentally, but that's it. That's our integral. It's really slick from here. Once you get to this stage, then the antiderivative is straight up from there. It's real nice. That means the one next to it, similar.
The 1/2, doesn't it also go to the...
Oh, there's two of them.
So
Hey,
the
yeah, thank you. I knew I was going to forget that. You just kind of tell it's going to happen. There's a 1/2 here, and there's a 1/2 that's part of it. Thank you. So it's 1/4. Gracias, Rachel. Those extra double 1/2s. Yeah, keep an eye on me for those. Next one then falls into place. I'm not going to work it out totally, but we would just bust it up. And so can you imagine that you just take sine cubed x and make it sine squared times sine? Which means then I can use this little formula that I have here, this power reducing formula. This is my sine squared, saying sayonara. Okay, I'm going to write that underneath that it's sine squared. And then next to it is a